In this video, we're going to look at worksheet 832, where we are going to use elimination. But when we look at these equations in our system, we're not going to have opposite coefficients to begin with. So unlike the first worksheet, we're not going to be able to just go right in and add. We're going to have to go to step 2 here, where we're going to multiply one of the equations by a number that will create opposites. So if we take a look at our first system here and following our steps, we want to make sure the equations are in standard form, which they are. We then want to look for opposite coefficients. As we look at the coefficients for the letter x, 3 and -1 are not opposites. As we look at the coefficients for y, we have -6 and -6. Now those are not opposites, but they're very close to being opposites. The only problem is they're both negative. If one of them was positive and one of them were negative, we would have opposite coefficients. So I can go to step 2 here and use the property of equality that says we can multiply an equation by any number that we would like, our choosing, as long as we're careful to do that to every term that's in the equation. So the way to make this negative sign a positive is to multiply it by a -1. By multiplying by -1, it won't change the value of 6, it'll still be 6, but it will change the sign from a negative to a positive. So we're going to decide then, or choose, to multiply the second equation by a -1. In doing so, that's going to create opposite coefficients. So what I like to do is I write this -1 above every single number that I'm going to multiply it by. Don't forget to do this one over here, the constant. A lot of times students will do this side but forget about the other side. The property says you got to do it to every term in the equation. Now I'm going to change the second equation when I multiply it by a -1, so I'm going to rewrite the first equation underneath here because I am going to add those together. So just so I can line these up with my new equation, I'm going to take my first equation that I'm not changing and rewrite it, and now I'm going to multiply this second equation by -1 and write that new equation underneath. So when I multiply a negative times a -1 here, that's going to give me positive x. The -1 times the -6 is going to give me positive 6y, and the -1 times the -15 is going to give me a positive 15. I now have two new equations, and this new equation is equivalent to the original one because I multiplied everything by the same number. But that did create for me opposite coefficients, which is what I'm looking for. So now this looks exactly like the first worksheet that we did. We simply are going to add these equations together, and the terms with opposite coefficients will be eliminated because they're opposites. So I have 3x and x, which would be equal to 4x. The 6x and the 6y and -6y are now equal to 0, therefore the y is eliminated. And 15 minus 3 is 12. I can then solve for x by multiplying by the reciprocal of that 4, or dividing by 4. And when we do that, we're multiplying these fractions, so we can reduce this 4 to a 1. That gives me x. And then this reduces to a 1 and 3. So I now have the x value of my solution, which is the number 3. Now I can go back to any of the equations in my system, the original ones, or even this new one that I created, and substitute this value of x into any of those equations to determine the y value. So I'm going to go ahead and substitute it into this new one I created, and so that's going to give me x. Nope, not x, because I now know what x is. I'm going to substitute in the value of x. X is equal to 3, so that's going to be 3 plus 6y is equal to 15. And now I have an equation with just the variable y, so I can solve this for y. So 3 minus 3 is 0, leaving me 6y. 15 minus 3 is 12. And then multiplying by the reciprocal of 6, or dividing by 6, the 6 is reduced to 1, and then this ends up being 2. So my y value of my solution is the number 2. So 3, 2 is the solution to the system that I arrived at by using the elimination method. And all I did was, because I did not have opposites in step 1, I just chose to multiply by a number that created opposites, in this case, -1. On number 3 on our worksheet, again, we're going to go through our steps. We're going to look and see if we're in standard form, which we are. We're going to look for opposites first. X, 1 and 1 are not opposites. 4 and -5 are not opposites. But just like the last example, 1 and 1 are almost opposites. The only problem is that they both have the same sign. So I can change the sign of 1 by multiplying it by a negative sign. As long as I do that to every term in the equation, the step 2, I am going to be okay. So I'm going to this time multiply the first equation by a -1. So again, I'm going to write -1 next to every term to make sure that I multiply every term by a -1. Because I'm doing this, I'm not going to rewrite this second equation because I'm just going to line up my new equation underneath it when I multiply by -1. So -1 times positive x, it gives me -x. The -1 times this positive 4 makes that -4 now. And the -1 times the -13 now gives me a positive 13. So I have two new equations in my system, and the system has these first coefficients that are opposites. So I can go ahead now and add these together, and that's going to eliminate my x variable. So x minus x is 0. -5 and -4 is -9. 14 and 13 is 27. So because I created opposite coefficients, when I added these together, my x variable is eliminated. I can now solve for y. So multiplying by the reciprocal of -9, which is -1/9, I can then reduce the -9's, leaving me 1 times y, which is y. And then this 9, and this reduces 3, and 3 times a -1 is -3. So the y value of my solution to the system is a -3. I now need to determine the x value, and as always, we can go back to the two original equations or the new equation that I created by multiplying by a -1, substitute in the value for y, and determine the x. I'm going to go back to this middle equation right here and substitute into this equation with the y value that I now have. So I have x minus 5, and then I have a y value of -3 is equal to 14. I then am going to multiply -3 times -5 is positive 15. Now I can add the opposite to isolate that x term on one side by itself. So 15 minus 15 is 0. 14 minus 15 is a -1. So the y value of my solution is -1. So the ordered pair -1, -3 is the solution to my system using the elimination method. Okay, I'm going to do just one more off of this worksheet, and because on this worksheet every single problem we have coefficients that are almost opposites, meaning they're the same number, they just have the same sign. And the only thing I need to do then would be to multiply by a -1 to create the opposites that I need. So we'll do one more, but everything on this worksheet will follow that pattern. And then in the next video we'll take a look at some where we can't just multiply by a -1, we're going to have to choose a different number. As we look at number 5, we're going to follow our steps. So we look and make sure our equations are in standard form, which they are. We then look for opposite coefficients. -4 and -3 are not opposites. 4 and 4 are not opposites. But 4 and 4, the only reason they're not opposites is because they're both positive. So to change the sign of any number, we simply multiply it by a -1. So if I multiply one of these two equations by a -1, that's going to create opposite coefficients here, which will then eliminate when I add those together. So I'm going to take the second equation here again, and I'm going to multiply it by -1. So I'm going to write a little -1 by each term to make sure I remember to multiply every term by -1. Now because I'm going to add these equations together after I multiply by -1, I'm going to recopy this first equation down here because I'm not changing it. That way I can line up the terms when I multiply by -1. So taking my second equation then here, -1 times -3 is going to give me a positive, well, I don't need to write a positive sign there. That's going to give me a positive 3x. -1 times a positive 4 is -4. And then a -1 times 2 is a -2. So I have now created the opposite coefficients that I need with the y variables by multiplying by a -1. So I can go ahead and add these equations together now. So -4 and 3 is, oops, get my pen here, -x. 4 minus 4 is 0, and then -4 and a -2 is a -6. I then need to make this negative sign positive, so much like I did on the other equation, I'm just going to multiply by a -1, and that's going to change the sign of everything. So this negative times negative becomes positive, and this negative times negative becomes positive. So the x value of my solution is the number 6. To determine the y value, I go back to any of the two original equations or the new equation that I created by multiplying by a -1. I can substitute the value of 6 in for x now and determine the value of y. Let's see, I'm going to go back to this new equation that I created and substitute into that one. So I've got the number 3 and then x, which I now know is 6, minus 4y is equal to -2. I now have an equation with just the letter y, so I can determine its value by isolating it. So 6 times 3 is 18, so we multiply first. We then are going to move that 18 to the other side by adding its opposite. 18 minus 18 is 0, so that leaves me -4y. And then I have -18 and -2, which is -20. I then am going to divide by -4, which is multiplying by the reciprocal, or multiplying by -1/4. So the 4 in the denominator, -4, reduces with the 4 in the numerator, leaving me 1 times y, which is y. 4 reduces with 20 is 5, so I have a -5 and a -1 multiplied together gives me a positive 5. So 5 is the solution, the y value of my solution. So the ordered pair 6, 5 is the solution to my system that I found using the elimination method. In the next video, we'll take a look at PQ 833 and look at multiplying these equations by a different number other than the -1 that we got to use on this worksheet.